Alright, please add this to the next page in your notebook. The title is IXL Level M, L5. Alright, so go ahead and pause the video and copy this down. And we're going to look at these two examples. So we are concerned about the index, the exponent of the radicand, and the exponent of the answer. So when we're in IXL, we got to pay attention to these. So first, the index here is 2. If it's not written, it's always 2. And so we're worried about when the index is even. So when I have an even power on the inside, there's two different cases that can happen. Now, one of the advantages of working with our rational exponents is you could rewrite this as x to the 8 over 2. And then if you simplify that, you get x to the 4th. So sometimes an even divided by an even equals an even. And there's nothing wrong with that. That's perfectly fine. The other instance is when I have an even divided by an even. Sometimes I get an odd. So if we do the same thing, take our radical form and go to rational exponent, so 10 over 2, and 10 divided by 2 equals 5. Everything looks great, except the problem here is since this is a positive and we don't know what x is, if x happened to be a negative, and if you think about it, a negative times a negative times a negative times a negative times a negative, that would equal a negative. Over here, I don't care about what the sign is, because a negative times a negative times a negative times a negative is going to always equal a positive. So when my answer is even, I don't care because it will always force it to be even, or positive. But when I have an odd exponent as an answer, then I have to worry about the sign. And so I'll force it to be positive by including these absolute value bars. So basically what I've done is I'm just going to work through some examples from IXL, and I'm starting at 0 and working my way up. So you can kind of follow along. So if you get stuck at 30, you can kind of just jump ahead and find where you think that would be. Alright, so here, both my indexes are even. And so if I rewrite this, this is x to the 18 over 2. 18 divided by 2 gives me x to the 9th. And since my exponent's odd, I'm going to force it to be positive with the absolute value bars. Here, rewrite it as 20 with the index of 2. 20 divided by 2 gives me x to the 10th. Since it's even, my answers will always be positive, so I don't need the absolute value bars. So the way I'm going to think about this one is I'm going to break this up into two problems. One with the number and one with the variable. And on my calculator, I'm going to see, can I take the cube root of 125? Now, if you wanted to, you could obviously do the birthday cake and see that 125 does break down. But since you have a calculator, you should use it. And so I know that's 5. Here, again, I want to use the idea of rewriting my radical with a rational exponent. And so this would become 12 over 3, and 12 divided by 3 is 4. Now, since this is an odd, I don't have to worry about the absolute value. I only worry about the absolute value when my index is even. So my answer here would be 5x to the 4th. Now if you didn't want to use the rational exponents, and you did do the birthday cake on this one, you would have got 5, 5, 5, and then you would have wrote x out 12 times. So if you really expanded it out, and then you grouped them in 3s, so that would come out. And then I would group my x's in 3s. So 1 comes out, another one comes out, another one comes out. So there's a total of 4 x's that were able to come out, and so that's why it's 5x to the 4th. So at this point in time, I'm hoping that you find the method that works best for you. The great thing about expanding it is it's very visual and you can see what's happening. Alright, so our next problem has an even index, so I have to be concerned about the absolute value. Again, I'm going to kind of break this up into 2 problems. And so it's the square root of 441. And here I'm just going to go ahead and write this as x to the 14 over 2. And again, on my calculator, I'm always going to try, can I take the square root of 441? And it works out. It's 21. And so now 14 divided by 2 is 7. And so whenever you divide and you get that odd exponent, so when you're dividing by an even and your answer is odd, you have to put the absolute value bars around it. Alright, now this is the one in Excel that I always mess up on. So I'm going to break it apart. And for some reason, I don't know, just the square root of a square, I just kind of forget the rules sometimes. So you got to remember that this index is a 2. And so whenever it's a 2, we got to follow our rule. And so this becomes exponent, index. And so we'll try the square root of 900 is 30. And 2 divided by 2 is 1. And so I have to include the absolute value bars. Alright, so I'm going to break this apart. Cube root of 216 times x to the 18 over 3. Since this is odd, I don't need to worry about the absolute value bars. The cube root of 216 is 6, and 18 divided by 3 is 6. Alright, so our next example is a square root. So you could always just expand it and write x 13 times. Or you could think about it as x squared times x squared times x squared until your exponents added the 13. And so we have 2, 4, 6, 8, 10, 12, and so I would need one more x to the power of 1, so all my exponents add to 13. Or the way I would actually think about it is x to the 12th times x to the 1, because all 3 of these are equivalent. They all equal x to the 13th underneath. But now here, if I split these apart, this one, if I rewrite it as 12 over 2, 12 divided by 2 is equal to x to the 6. And so that's why I wanted that 12, because it was divisible by our index. And since I divided by an even, and my answer was an even, I don't need to worry about the absolute value bars. So now just come back and take a look. There's 1, 2, 3, 4, 5, 6 x's, so that's why it's x to the 6. If you did it by x squareds, 1, 2, 3, 4, 5, 6, and then on each one of these, that x is still on the inside. So now we're going to take the square root of 175x to the 10th. So our index is a 2, so we are worried about the absolute value bars. So this is going to become the square root of 175 times, let's just go ahead and rewrite it as x to the 10th divided by 2 of our index. And so here on the right, that gives us x to the 5th. And since this is odd, I divided by an even and I got an odd, I will need the absolute value bars. Now you can't square root 175, so this would be an example of where you would want to use the birthday cake. And that would become 5 times 5 times 7. And so I have two 5's repeating. So I get to write 1 5 on the outside. Now this is kind of an awkward way to write it. And so what I'm going to do is I'm going to put the 5, then the x, then the square root. So this is how you'd want to type it into IXL. Alright, our last example. We have even power, so we have to be aware of this. So I'm going to rewrite it as the 4th root of 81 times x to the 4 divided by my index of 4. And so here, this becomes x to the power of 1, so this will need the absolute value bars. Here, 81 is going to break down to 3 times 3 times 3 times 3. So the 4th root of 81, and I guess I could have tried that on my calculator. I guess that would have been a better start. Just take the 4th root of 81, I know what I got, 3 times the absolute value of x. So this should be enough to get you through up to 70 on IXL.